Let's talk now about these cases where there isn't a clear distinction between servers and clients. For instance, if you look at all of the big data applications that we hear about today, the state of the application is distributed and stored across all nodes. The processors on these nodes run certain applications such as data analytics codes, data mining codes, searching for patterns, or searching in order to answer your Google web search requests or some other applications, and they access the state that's distributed across all the other nodes in the system. The key about these applications is that every node in the system owns some portion of the state. By own here, we mean that there's some state that's locally stored on a particular node or that's generated by computation that's running on that node. So the overall application state is the union of all of these pieces that are present on every one node. It's as if all the nodes in the system are peers. They all require accesses to the state anywhere in the system, and they all provide access to their locally stored state to any of their other peers in the system. For instance, think about the large web search applications like Google. The state in that application, which is the information about every single web page in the world, is stored on many machines, and at the same time, it's also processed on all of them. Whenever you type in a web search, it may get processed on a different processor in this distributed system, but the state that's required for that web search, regardless on which processor it hits, may be somewhere on some of the other nodes. Applications like Facebook and YouTube also have state that includes billions of images and videos, and these images and videos are processed to detect certain objects, to transform them into different formats and sizes. So there's some computation that's performed on that distributed content. The code that performs these processing operations, these transformations, transcoding of the videos or the images, may run on different nodes in the system, but may potentially need to access state that's distributed on other nodes. These applications are examples of applications where every node is responsible for managing the locally stored state and providing access to the locally stored state, but also at the same time accessing the state that's stored by the remaining nodes in the system. The reason I'm putting the term peer here in quotation marks and not using a popular term that you may have heard of, peer-to-peer systems, is that in these kinds of distributed applications, it is still possible that there will be some number of designated nodes that will perform some overall management and configuration tasks for the entire system. So there's some portion of control plane tasks or management plane tasks that are performed by some more centralized designated set of nodes that's not evenly distributed among all nodes. In a peer-to-peer system, even the overall control and management of this system would be done by all.